Hi everyone, welcome to my channel. Subscribe and hit the bell icon.
We often use vehicles like bike, car, bus, lorries, trains, and more, to travel, transport shipments, and for so many things. So every vehicle need petrol or diesel as fuels. But wait, petrol or diesel, how it made, where does it come from, what is the difference between petrol and diesel, petrol engines and diesel engines, how they work and which is better? Let's see. What is crude oil? Well, crude oil is a naturally occurring unrefined petroleum product composed of hydrocarbon deposits and other organic materials. Crude oil can be refined to produce usable products such as gasoline, diesel, and various other forms of petrochemicals. It is a non-renewable resource, which means that it can't be replaced naturally at the rate we consume it and is therefore a limited resource. How it is formed? The crude oil formation happened millions of years ago. Fossil fuel that has been formed from a large amount of died plants, animals, prehistoric algae, and zooplankton, whose remains settled on the bottom of an ocean or lake. Over time, this organic material combined with mud and was then heated to high temperatures, from the pressure created by heavy layers of sediment. This process, known as diagenesis, changes the chemical composition first into a waxy compound called kerogen. If this kerogen is continually heated, it leads to the slow release of fossil fuels, such as oil and natural gas, and also the non-fuel carbon compound. How to extract crude oil? Geologists search over water and land to find crude oil and gas using seismic technology, the range of geophysical imaging technologies that can detect reservoirs under thick layers of salt deep below the seabed. They record waves for best picture from beneath the surface in the site which they are surveying, using advanced microphones as the waves pass through or bounce off the different layers, rocks, and sediment deep underwater. And they turn the seismic data into images with high-performance computers, using advanced algorithms to produce an accurate geological map of the site investigating. If it is confirmed, the drilling barge arrives at drilling site and moves into the exact position with help of satellite. It has 6 propellers to prevent it from drifting due to the wind and waves. First, the conductor pipe is installed to the drill pipe. The conductor pipe and guide are sent down to the seafloor. After the conductor pipe penetrates the seafloor, drill pipe is released and pulled back to the vessel, then connects the drill bit at the bottom of the drill pipe and sent back into the seafloor. The drill bit is led down to the bottom of the hole, through the conductor pipe, and starts drilling the sediment and rock below the seabed. At the same time, seawater is sprayed from nozzles on the drill bit to raise the cuttings to the seafloor. After drilling several hundred meters, the drill bit is pulled back. A casing pipe is sent down through the conductor pipe and inserted into drilled hole to keep it from collapsing due to high pressure. To fix this casing pipe, cement is pumped into the space between the hole and the casing pipe. After cementing, the riser pipes pulled back and connected to the other device called blowout preventer at bottom of the riser pipes. The blowout preventer is used to seal, control, monitor, and prevent blowouts, the uncontrolled release of crude oil or natural gas. If crude oil mixed into seawater, it pollutes seawater and cause to die living creatures of the sea. The blowout preventer is sent down and connected to head of the casing pipe. Again, drilling continuous, but this time special mud is used instead of seawater, repeating this process until they gets results. If it goes success, first natural gas will be stored in container, next crude oil, and sent them to the refined companies. Let's get into our main process, separation of crude oil. Fractional distillation is used to separate crude oil into simpler, more useful fractions. Crude oil is a complex mixture of hydrocarbon molecules. Small molecule chains have low boiling points, and longer molecule chains have high boiling points. Very small molecule chains stay as a gas. Normal small molecule chains turns into petrol, medium molecule chains turns into kerosene, and large molecule chains turns into diesel. These all molecules are mixed in the crude oil. They turns into vapor at different temperatures, like gas at low temperature, kerosene at medium temperature and diesel at high temperature, so that each fraction evaporates and turns into fuels. All hydrocarbon molecules have very strong chemical bonds between atoms. They also have a weaker force of attraction between molecules. This is called an intermolecular force. Longer hydrocarbon molecules have a stronger intermolecular force. More energy is needed to move them apart, so they have higher boiling points. This makes them less volatile and therefore less flammable. Firstly, the crude oil fed into the fractional distillation column, which is about 1050 degrees Celsius heat at the bottom and 50 degrees Celsius at the top. When crude oil is boiling, all the hydrocarbon molecules evaporates and turns into a gas. As the crude oil vapor ascends the fractionating column, the trays are fitted at certain temperatures in the column. When the boiling point arrives, vapor turns back into liquid, and the remaining continue moving up of the column and condense when they reach their boiling points. For example, diesel boiling point is 250 to 350 degrees Celsius. Bottom of the column is higher temperature, right? So diesel molecules are in the form of gas. When gas goes up of the column, and of course the temperature is getting lower, when it reaches 250 degrees Celsius means less than its boiling point, that gas will be changes into liquid form, and that is diesel. The small chain molecules are not condensed, they are removed from top of the column as a gas, and very big molecules that doesn't vaporize at 1050 degrees Celsius, it is called bitumen and used for laying roads. Now let's take a look at the difference between diesel and petrol engines. The diesel and petrol engines that are used in most cars, in essence they are internal combustion engines that work using a 2 or 4-stroke cycle. Let's see 4-stroke engine. In the first stroke intake phase, the piston pulls an air-fuel mixture into cylinder through the opening intake valve. In the compression phase, the intake valve closes and air is compressed with fuel. At this point the mixture of fuel and air is ignited to cause an explosion. It is this explosion that causes the piston to downwards and drive the crankshaft to produce motion. This is the power phase. The final phase is exhaust, where the spent air-fuel mixture is expelled out of the cylinder through the opening exhaust valve so that a new cycle may begin. Petrol and diesel engines operate using the same principle, but the difference is that petrol engines use spark plugs to ignite the air-fuel mixture, while diesel engines rely solely on heavily compressed air. In diesel engines, air in cylinder would be very heavily compressed, typically around 14 to 29 times. In petrol engines the compression ratio is generally much lower, because they rely more on the spark plug to begin the power phase. The compression ratio in petrol engines is typically around 7 to 10. High compression ratios are desirable because it results in higher thermal efficiency. In other words, more energy can be extracted out of the air-fuel mixture. Now, which is better? The diesel engines are considerably more efficient than petrol engines. In fact, diesel engines have the highest thermal efficiency of any internal combustion engines. The diesel fuel is denser than petrol and contains about 15% more energy, By volume roughly 36.9 megajoules per liter compared to 33.7 megajoules per liter of petrol, the difference in energy density, the overall efficiency of the diesel engine is some 20% greater than the petrol engines. Now let's see about diesel engine noises, combustion noise. Indeed, diesel engines produce knocking such as impulsive and irregular noises which are unpleasant, high compression vibrations. We need many pistons to manage it, but automatically increases of structure, weight, and budget. This may be the main drawback of diesel engine bikes of Kawasaki and Royal Enfield companies. Petrol and diesel have their own advantages and disadvantages. What happens if we filled with diesel in petrol engine car? When diesel is filled in a petrol engine, the diesel does not evaporate like petrol and there will be no spark. If you don't get your car started and stops. Be aware though, even without starting the car, it can clog the fuel filter and ruin all of the fuel injectors. If you do start the car, the diesel will land up filling the cylinder bores and causing a hydraulic lock. This can in turn cause damage to your conrods and crankshaft. This is a vital element to your engine. It will also leak into the sump, which will result in your oil being affected. Although this will probably not destroy your engine completely, it will have a serious impact on the car. Let's keep them aside. Let's see about kerosene's performance, which is in between of both petrol and diesel performance. Kerosene is widely used to power jet engines of aircrafts, and some rocket engines, and is also commonly used as a cooking and lighting fuel. Hope you understood separation of crude oil. That's it for this video. Thank you for watching. If you like this topic, hit that like button, subscribe our channel, share with your friends, and comment next video suggestions.